See, coming to linear algebra is concerned, algebra, I believe you guys know what is mean by that. And regarding linear, just in differential equations also we have discussed. Okay, linear in the sense we are going to deal with linear equations. Okay, we are going to deal with linear equations. Okay, linear, but we are going to deal with algebraic equations. Okay, for example, if I take ax plus by equal to c, a1x, b1x, c1, a2x plus b2y is equal to c2. So I have taken two equation, right? And what about the power for this equation? If I consider the power of x is 1, power of y is 1, power of c 0. I can add x to the power of 0, so the power is 0. Similarly, here power of x is 1, power of y is 1, and power here x power 0, the power is 0. So maximum power is 1, or we can have 0 as the minimum power. So that is what we will be calling it as linear equation. And what about homogeneous? See, we already know this, just I am recollecting it. What about homogeneous? No, homogeneity in the sense what? The condition. The power should remain same. The power has to remain same throughout. Here power is 1, here power is 0, so obviously it is non-homogeneous. Just I am recollecting it. So what we are going to deal in this particular chapter, we are going to deal with these types of equation which will be linear, but it may be non-homogeneous or it may be homogeneous also. For example, the same thing, a1x plus b1y is equal to 0, a2x plus b2y equal to 0. What is this equation? It is linear because maximum power is 1, and also it is homogeneous because power remains same throughout. Okay, so it is linear and homogeneous. Okay, it is linear equation, homogeneous, non-homogeneous equations are fine, but what type of curve it is corresponding to? Enna madriyana curve? So obviously a straight line because power is 1. So this corresponds to a straight line, this corresponds to a straight line. And what does it mean if I want to find out, if I have two straight lines? Okay, I have two straight lines and I want to find out solution corresponding to the straight line. I will just take this two straight line itself. I want to find out a solution. What does it mean? Yes, the intersection point. Okay, for example, if I take straight line 1, consider that this is corresponding to first straight line a1x plus b1y, which is equal to c1, and this corresponds to second straight line, and the solution in the sense this point where it intersects x1 comma y1. This intersection point is nothing but the solution of those two straight lines. Okay, our ultimate aim in this chapter is to find out this. Okay, but for entering into this part, we are going to understand some basics of basics of linear algebra, basics of matrices. Okay. So this is one type of solution. For example, if I have a straight line 1 like this, and I have another straight line 2 which is also exactly coinciding with that. Okay, both are coinciding. Okay, this is 1, and I have straight line 1 like this, another straight line like this. They are parallel. Okay, so they, first of all, what type of solution is this? It is unique solution. I have only one solution. It is unique solution. There, infinite solution, infinitely many solution. What about that one? Yes, it doesn't have any solution. Okay. Now, coming to unique solution, when can I have a unique solution? Take an example of these two cases. When can I have a unique solution? Just with the help of equation. Equation மட்டும் வெச்சு நான் எப்ப unique solution சொல்ல முடியும் அப்படினு யோசிங்க. See, if our ratios of, or else mathematically to understand what I can say about 1 and 2, slope of 1 and 2. 1 oda slope, 2 oda slope. They should not be same. Okay, the slope should not be same. If the slopes are equal, then we might be getting a parallel line. Parallel line is possible, or else we will be getting a line which will be coinciding throughout. So the primary condition here for a unique solution is our slope, or else I can say that the ratio of x coefficient and y coefficient should not be same. If this is the condition, then it will be having unique solution. Okay. Infinitely many solution in the sense the slope should be same. Okay, a1 by a2 should be equal to b1 by b2, and that should be equal to the constants ratio also. Okay, if it is equal to constants ratio, then the solution will be infinitely many. There will be number of solution. And what about no solution? The slope should be same. Okay, slope should be same, but it should not be equal to the ratio of the constant. Okay, these are basic algebra. Okay, basic algebra. அதாவது ரெண்டு ஈக்குவேஷன் என்கிட்ட இருக்கு, டூ அல்ஜிப்ரிக் ஈக்குவேஷன். அந்த ரெண்டு ஈக்குவேஷனை சால்வ் பண்ணி என்ன டைப் ஆஃப் சொல்யூஷன் கண்டுபிடிக்கணும்னா இந்த மூணு மெத்தட் யூஸ் பண்ணி கண்டுபிடிக்கலாம். ஓகே. See, these are corresponding to straight lines, right? These corresponds to straight line. Okay. What about this equation corresponds to, if I take an equation like this, a1x plus b1y plus c1z equal to d1, a2x plus b2y plus c2z equal to d2, a3x plus b3y plus c3z equal to d3. What about this three equation? It corresponds to என்ன மாதிரியான equation னு கேக்குறேன்? It's a plane surface. Okay, it's not a straight line, it's going to be a plane. Okay, so this is plane. Okay, and if I am going to find out a solution for this, what does it mean? The same thing, I am going to find out where it intersects. Okay, I am going to find out x1 y1 z1 or x2 y2 x1 y1 z1 or x2 y2 z2, in order to find out where actually it's going to satisfy all the three equations. Okay, right. Now coming to what is that, linear algebra is concerned, what we are going to do, our ultimate aim is to find out solution for the linear equations, but for that I am going to use a tool called as matrices. Okay, we know what is mean by matrix. It's a, what is that, it's an array. It is going to contain some number of rows, some number of columns. Okay, these are very basic ideas. Okay, suppose if I represent n cross m, n indicates number of rows. Okay, n indicates number of rows, m indicates number of columns, and this n cross m indicates order. Okay, order of the matrix. Okay, order of that particular matrix. So I will represent first row as my first equation, second row as my second equation, third row as my third equation, etc. So ஒரு row ஒரு equation நம்ம represent பண்ணுவோம், and by using that there are some methods. Okay, there are some methods, Cramer's rule, Gauss elimination method, etc. and what is the other one, matrix inversion method, etc. By using that I will find out the solution. Okay, right, and that is by using that I will find out the solution. But before finding out the solution, I need to know what type of solution, right? Whether the solution is unique or infinity or no solution. For that, I will use rank, concept of rank. And before entering into concept of rank, we need to know what is meant by determinant, what is meant by inverse, and some basic properties of matrices. Okay, so ultimately for reaching this point, we are going to understand matrices fully, and once we reach this point, we will be going through this. That is our primary aim of the chapter. Next will be eigenvalues and eigenvectors. Okay, what is eigenvalue, what is eigenvector, how it is going to be useful for us. And the last task, a smaller task, is to understand what is meant by vector spaces. It's not very important, but recent I don't remember exactly XE ME and that algebraic multiplicity, I think XE, algebraic multiplicity, geometric multiplicity, they have asked in I think it is XE, in XE paper they have asked. Vector spaces are not very important for ME, okay, not very important for ME, but that multiplicity concept, from that they might ask you in XE. Okay. So the things which we are going to discuss, okay, I mean, what are all the topics, what are all the agenda? First we will start with basics of matrices. Okay, chapters agenda. 2, I will focus on determinant and rank. Okay, determinant and rank of a matrix. You can parallelly copy this agenda of the chapter. In basis of matrices, we will discuss about what is that, types of matrix, transpose, okay, some properties related to matrices, etc., addition, subtraction, multiplication, etc., determinant and rank, and then I will be focusing on what is that, after determinant and rank we will be going for solution methods. Solution methods of homogeneous and non-homogeneous equation. Homogeneous and non-homogeneous linear equation. Homogeneous, non-homogeneous linear equation. Then eigenvalues and eigenvectors. Okay, then eigenvalues and eigenvectors, and finally I will be focusing on vector spaces. Just an intro, not in detail. Introduction to vector spaces. Okay, so these are the 5 topics. Chapter weightage gate le it is 2 marks or 1 mark. One question compulsory. One question compulsory. Gate பொறுத்த வரைக்கும் எந்த எக்ஸாமில் மேக்ஸ் இருந்தாலும் லீனியர் அல்ஜிப்ராலேருந்து கொஸ்டின் இருக்கு. See, types of matrices, I am not going to write down everything because everything is already there. I am just going to go through and then you are going to copy it. Okay, that ரொம்ப straight forward ஆ தான் இருக்கும். What is a row matrix, what is a column matrix? So I am not going to spend much time on this. Okay, right. First, real matrix. Real matrix means what? In a particular matrix, all the elements which is present will be real. Elements is nothing but the what is that? The elements which is present inside the matrix is elements, and this is my row, this is my column. If everything is real, it is going to be a real matrix. Sorry. Okay. What about complex matrix? If any one element is complex, ஏதாவது ஒரு எலிமெண்ட் காம்ப்ளெக்ஸாக இருந்தாலும் it is complex. See, these are very straightforward. I am not going to spend much time in this. Okay. Next, row matrix. You can answer row matrix. There will be only one row, but any number of columns are possible. As you could see, it has only one row, but any number of columns are possible. What about column matrix? Single column, but any number of rows are possible. So, in case of row matrix, the order will be 1 cross n. In case of column matrix, the order will be m cross 1. Any rows are possible, but only one column. Okay, again basic one. Null matrix, the matrix will have only zeros. Okay, everything will be 0. Next, rectangular matrix. M and nr, they are not same. If it is a square matrix, number of rows and number of columns will be same. Rectangular matrix, number of rows and number of columns won't be same. Okay, so our m value, n value, number of rows and number of columns are not going to be same. The matrix will look like a rectangle. If it is a square matrix, m and n will be same. Okay, again very basic idea. And what about diagonal matrix? It will have only diagonal element. Other than diagonal element, all the elements will be 0. Yes, other than diagonal element, everything will be, all the other elements will be 0. See, regarding elementary condition, I will talk about it. Just hold on for some time. Elementary condition, I will come back to it later. Scalar matrix. Any ideas? Scalar. Unit matrix. Scalar matrix na kekra. All diagonal elements will be same. See, scalar matrix is a diagonal matrix where all the diagonal elements will be same. In case of diagonal matrix, the diagonal element can be different. Okay, 2, -3, 0, 9, 7, 9, 4, the diagonal elements can be different. But scalar in the sense, all the diagonal elements should be same. Okay, 5, 5, 5, 7, 7, 7, etc. It should be same. Identity, that you know. Identity matrix is a scalar matrix where the diagonal elements will be 1. Okay, so instead of 5, 5, it will be 1, 1, 1, whatever case it is. Okay, second order, third order. Next is strictly triangular matrix. Strictly triangular. We have 3 types of triangular actually: strictly triangular, upper triangular, and lower triangular. If it is a strictly triangular matrix, see, lower triangular, upper triangular, I hope you have seen. What is that? Correct. Opposite to that of our diagonal, which means I will be having zeros in my leading diagonal, a leading diagonal or principal diagonal. Other than leading diagonal, principal diagonal, all the other element will be non-zero. Okay, so only, zeros will be present in my leading diagonal element. Okay, other elements will be non-zero if it is a strictly triangular matrix. Okay, elementary condition, as I said, I will come back to it. Now, upper triangular matrix, only upper half will be? Right, only upper half will be present. These elements will be there and this will be there. These 3 elements will become 0. Upper triangular na lower element 0 idom. Lower triangular means upper element will become 0. Okay, something like this. Upper triangular, lower elements will become 0 below leading diagonal. Lower triangular, upper triangular elements will become 0. Okay, singular matrix. No. Determinant should be 0. Okay. Determinant should be 0 for singular. Determinant should not be equal to 0 for non-singular. Determinant definition we will discuss later. Okay, as of now, don't worry. As of now, just keep the definition in mind. Determinant and the theory, properties behind determinant we will discuss later. Basics உங்களுக்கு கண்டிப்பா தெரிஞ்சிருக்கும். Okay, determinant தெரியாம இந்த V முடிச்சிருக்க மாட்டீங்க. I am damn sure. So, but we will discuss about the properties later. Okay, so if determinant becomes 0, it is going to be singular. So, just take a matrix and if I find out determinant, if it becomes 0, it is singular. Non-singular, determinant will not be 0. Okay. See, this is straightforward. There is nothing to explain. That is why I will PPT report and trace of the matrix we will see later. Okay. So, now what we need to understand here, elementary conditions. Okay. First, we will start with square matrix, rectangle matrix, row, column. We don't need to discuss elementary condition. What about diagonal matrix? Let me take a diagonal matrix. 3, 0, 0, 0, minus 2, 4, 0, 0, sorry. 0, this is 4. What type of matrix it is? What type of matrix? It's a diagonal matrix. Right. See, elementary condition in the sense, how I am going to represent this entire matrix as a single element. Or element base panni complete matrix na eppadi define பண்ணுவேன் அப்படின்ற மாதிரி தான். Okay, that is what elementary condition. Generally, we used to define any element in a particular matrix with Aij or Eij. E or A, it depends on the particular, E or I, it depends on the particular question. Okay, whatever. First row, second column, etc. Okay, so this is my first row, second row, third row, right? So I will be represented here 1, 2, 3. First row, second row, third row. J as concerned, first column, second column, third column. First column, second column, third column, etc. Okay, right. Diagonal matrix number, if when Aij will not be 0, say if Aij is 0, or else I will ask you in this way, if Aij is 0 இருக்கும் for a diagonal matrix, when Aij will be 0. When I and j are not equal. Okay, when I and j are equal, it may be 0, may not be 0. Diagonal element வந்து 0 கூட ஆகலாம். இங்க -2 க்கு பதிலா 0 கூட இருக்கலாம். When Aij will not be 0, say if Aij is 0, or else I will ask you in this way, if Aij வந்து 0 இருக்கும் for a diagonal matrix, when Aij will be 0. When I and j are not equal. Okay, when I and j are equal, it may be 0, may not be 0. Diagonal element வந்து 0 கூட ஆகலாம். இங்க -2 க்கு பதிலா 0 கூட இருக்கலாம். My diagonal element can become 0, but the condition is if I and j are not equal, then my Aij will be surely 0. So Aij will be equal to 0 if I is not equal to j. This is not elementary condition. Okay, that is how I need to define an elementary condition. Okay, complete matrix or condition mari represent or elementary or a condition which represent an element. Okay, that is elementary condition. Okay, this is for diagonal matrix. If suppose, what is the next one? Scalar matrix. One second, I will just take some example. I will take k 0 0 0 k 0 0 0 k. Okay, aij or eij will be equal to 0 for I not equal to j. It will be equal to k for I equal to j, because just this elementary condition will state diagonal. அது diagonal இருக்கலாம், but ரெண்டு elementary conditionும் include ஆனாதான் it will be a scalar matrix. Okay, is it clear? That is for scalar. What about next after scalar? A triangular matrix we can start with strictly. Okay, identity matrix is easy, right? Identity matrix, instead of k, what I should have? Aij should be equal to 0 when I is not equal to j, is equal to 1 when I is equal to j. Okay, scalar identity is done. Strictly triangular. Aij, let me just 1 second, I will write down the example. It is going to be 0 0 0 minus 1 3 2 4 5 7. Okay, aij will be equal to 0 when I is equal to j. Okay, when I and j are not equal, then my aij may not be equal to 0 or may be equal to 0. Okay, it can be or it cannot be. Okay, right. Next, what about upper triangular matrix? Upper triangular matrix. 2 3 7 0 4 8 0 0 3. Okay, this is my upper triangular matrix. When I is, this is 1 2 3 1 2 3. When I is greater than j, what will happen to aij? I greater than j and aij will be 0. My aij will be 0 when I is greater than j. Okay, aij will be 0 when I is greater than j. Next, lower triangular. See, for lower triangular you can directly say lower triangular matrix. Aij will be when I is less than j or j is greater than I. Okay, vice versa. Anything else I left out? I think that's it. You'll just check it. Lower triangular, for other things we don't. Singular matrix la thevilla. Okay, elementary condition eludha mudiyadhu in fact. Okay, see, this condition you leave as of now. In the condition ipathikku leave it. Note la irukradhu na the problems moolama explain pandren. This condition just leave it. This condition I have explained it, you can write down. Okay, this alone you can leave. As of now, leave it. I will explain it through problems. Okay, can copy. Quickly you have to copy. Definitions la full ah eluduvana. Short ah ungalku example eludittu short ah definition eludhikonga. That is enough. Types of matrices.